lesson. My name is Edward Siani, a teacher from Gatete Body. I'll take you through the topic probability. In probability, we are going to look at 3 diagrams. So you are welcome to the lesson. First thing first, we are going to define probability. Anyone to define probability for us? Shirofia?
It's a numerical measure of likelihood of required outcomes happening.
In numerical order, okay. Imagine you have an event, and that event is A. Event A. So, for that event to happen, there must be a number of favorable events. Number of favorable events divided by the number of all possible outcomes. So that's the definition of probability. Definition of what? Probability. So the other definition we are going to look at is a compound event.
A compound is something which can be split down to 2 or more simpler substances.
Okay. Events. Good. That form one trial of an experiment. The last one that we need to define is a sample space. Sample space. In probability, when we talk of a sample space, what are we referring to? This is the total number of outcomes. Okay. With this in mind, we can now look at 3 diagrams. I'm sure you know that every tree has what? Branches. Very good. So we will be using branches to demonstrate these events or compound events. Who has a coin here?
Yes.
Okay. Bring that coin. Can you toss that coin?
Head or tail?
Hands.
Loudness. Tail.
Why is it necessary to toss a coin? Or to shuffle cards? Those who have played playing cards before. Why is it necessary? Yes.
To avoid the repetition or guessing.
Okay. So that you have a fair play, right? Yes. To level the playing field, right?
Yes.
And to avoid people guessing, right?
Yes.
Okay. So it's important to toss the coin. Now, a coin has only 2 outcomes. What are those? Yes, Magdalena.
It has either a tail or a head.
Either tail or head. A coin has only two outcomes. That is to say, head or tail. If I can ask, what is the probability of getting a head? Please.
1 over 2, that is half.
1 over. Probability of getting tails or a tail. What's the probability of getting a tail?
It's 1 over 2.
Again, you see? 1 over 2. Right? Okay. So, if we add the two probabilities, what is the highest number we can get? Yes? 1. So, there is no probability which is greater than 1. It ranges from 0 to what? 1. To 1. And we write probability will range from 0 to what? To 1. What is the probability that the sun will not rise tomorrow?
0.
It's 0. Right?
Yes.
It has never happened, right?
Yes.
Except maybe in biblical times, right?
Yes.
Okay. So, between 0 and 1, there are a lot of numbers, okay? Which you are going to see as we answer this question. So the question here is asking us to find what? To draw what? A tree diagram. And we know that a tree has what? First, we look at the sample space. I think we have talked about probability of head is half, and probability of tail is also what? Half. So meaning that the first branch is going to have the head and the tail. Now, the probability of head is what? Half. And this one was half. And we know that half plus half is 1. So every branch must give us 1. So we consider this as the first toss. Right?
Yes.
We can consider this as the first toss. Because the question requires us to toss it twice. Right? It was tossed. Are you seeing this? Yes. So this is the first toss. We toss from this branch. We are going to have again head and tail. This branch will also give us head and tail. Okay. So, what is the probability of tossing a head? Half, right?
Yes.
Probability of tossing a tail is also half. Probability of tossing a head is half. A tail, half. Because there are only two possible outcomes. Okay?
Yes.
Let's look at the outcomes. The outcome. What is the outcome on this branch? It's a probability of 2 heads, right?
Yes.
Probability of getting in 2 heads. It's a probability of getting in
2 heads.
And this tells us that the first head is what? Half. We multiply by half. Why are we multiplying? Because it's a probability of what?
1 over 2.
But why are we multiplying and not adding?
Because we have two heads.
Two heads. Okay? We are saying what is the probability of producing both heads being what? Both probabilities being heads. Right?
Yes.
So the word both or and means what? Multiplication. So what's the outcome there? 1 over 4. We look at the probability of what here? Getting a head and the tail. This also gives us by then the outcome there. What about the third probability? It will be probability of what? Tail and head. Probability of getting the tail and the head. Which also gives us what? Half by half to getting important. The last probability. What is the probability? The probability of getting two tails. Which also gives us half multiplied by half to get what? Quarter. Okay. Now, what will happen if we add all the quarters? All these probabilities. What will be the outcome? So if we add all these, we should get what? 1. Because there is no 2. There is no 1.5. Numbers range from 0 to 1. Okay? Yes. How best can we use probability? Okay, games of chance, right? Yes. How best also can, apart from games, look at the bulbs. The bulbs. They are manufactured where? In industries, right? Yes. I can use probability to determine if the production is higher or lower, or how many 40 bulbs we are going to produce by using what? Probability. Some of you will be managers in those institutions. Okay? So it is used in many fields, in hospitals. You can go to the hospital and ask how many people had malaria the past 5 years, and how many got healed from particular drug. It's a research based on facts, right? Okay. So let's look at the first activity on tree diagrams. A bag contains 7 red and 3 white identical balls. They are identical, right? Yes. The 2 balls are taken from the bag at random, one after the other, without what? Replacement. So you get, you don't replace, right?
Yes.
There are 2 types of tree diagrams. There is a probability without replacement and probability with the replacement. But this one is it without what? Replacement. Okay. Come.
The question says we have red, 7 red, and then white, 3 identical balls. Then we draw a tree diagram. Red here, white here. Then we'll add the balls together, which will give us 10. Meaning all together have 10 balls. Then we'll say 7 out of 10, then 3 out of 10. Since they are saying they get 1 without replacement, meaning we'll draw another branch here. This one will be red, this one will be white. Then they have removed 1 ball, meaning we'll remain with 6 out of 9, then 3 out of 9, and then another branch, red, white, 7 out of 9, then 2 out of 9. Then we'll come up with outcomes now, which would be probability of red, 7 out of 10 times 6 out of 9, which will give us 40. 3, 2, 5. This times this will give us 21. Then this times this will give us 45. And then this one and this one. So probability of red and white will be 7 out of 10 times 3 out of 9. This times this is 21. This times this 9. Then this one and this one. So probability of getting white and red 3 over 10 times 7 over 9 should give us 21 over 9. So the 3 out of 10 times 4 out of 9, which will give us 3 over 45. This one, 1, 5. And this times this 3, this times this 5. So we will remain with 1, and then 1 over 2.
Okay. Stop for. Alright. How was the explanation?
Yes.
Good. Can I take you through again?
Yes.
Okay. So she started with a sample space, right?
Yes.
Where she added there are 7 red balls and also 3 white balls. This gives us a total of 10 what? Balls. Good. It's important first to start with the sample space. Okay. And then the first toss, she drew a branch of two branches because we need a red and a white branch. So in the first toss here we have 7 out of the total, which is 10. And then we have 3 also out of what? 10. Now if you add the 2 branches, what is the total sum of the 2 branches? Yes? It's always what?
1.
Every branch must give you 1. Okay? Then we'll go for the second toss. We also use the 2 branches. Again, we're going to have red and white. And here we're going to have red and white. Okay, because we have picked without replacing, imagine you pick without replacing, then are they 10 again?
No.
Okay, so there will be 6 red because here we are just going to pick on what? Red. We will not pick on white. Right?
Yes.
Then the next time we will not pick red, we will pick what? White. Okay? So if we pick red, there are 6 out of 9. We haven't picked this, there are 3 out of 9. Because the denominator has also been what? Affected. If you add the 2 probabilities, you will also get what? 1. So when we come to this probability, we are going to write 7. We haven't picked 7, but the denominator will be 9. Because if we pick from this one, there will be 2 out of what? 9. Again, you add the 2 probabilities. What do you get? Get 1. So the outcomes, we are going to have probability of picking 2 red balls, which is 7 out of 10. We multiply by 6 out of 9 to give us 42 out of what? 90. I know we can simplify, but it is not necessary until the final answer. It makes life easier. Okay? And then probability of picking what and what here? Red and white. So here you have, what do you have here? 7 out of 10 and 3 out of 9 to give you 21 out of 90. Okay? Here it will be probability of white and red. This will give us 3 out of 10 by 7 out of 9. This ends in 21 out of 90. And the last one is probability of 2 white balls. Probability of picking both balls being white. So this is 3 out of 10. We multiply by 2 out of 9 to give us what? 6 over 9. If we add all these probabilities add together, the answer of what? 1. Okay? Now, we come to the questions. We have questions now to answer. Because we have a tree diagram, we can easily now answer these questions. Because the tree diagram is already there. This makes life easier. The first question is, we have drawn the tree diagram, right? Probability of taking at least one white ball. We are talking of probability of at least one what? One white ball. Can I learn from you? If I say, can I have at least 2 girls in front? At least 2 girls come in front? So what is the class learning about the word at least? Yes, ma'am.
The word at least can mean 2 or more.
Exactly. It can mean 2 or more. Thank you very much. You can take a seat. And here we go. To answer this question, find the probability of taking at least one white ball. Yes, come again. In fact, that's what I want. I want you to shine, right? So that
The question is saying at least one white ball. Then we'll leave this part, then pick this and this and this. Then we'll add and this to find the probability of getting at least one white ball. Use 42 out of 90 plus 21 out of 90 plus 21 again out of 90. Since we are adding, we look for a common denominator, which is 90. Then 99 is 1 times 42 is 42 plus 99 1 times 71. Then we'll add this amount. We'll have 84. Out of 90. Is there a number which can go in this and this without giving a 2 into 8, 4. 2 into 90. 45. Any number? That's the probability of at least getting one white ball.
they are still insisting that you still reduce this fraction.
Yes.
What is the common factor? 3. So divide by 3.
It will give us 1 over 14 out of 15.
Since they have said at least one white ball,
Yes.
so why did she include 42 over 90? Because that one is for red to red.
Oh. She was supposed to have what?
Red to
At least one white. Suppose we have this one, and this one, and not this one. Okay? Okay, let me explain. But the explanation was good, right? Yes. You have to show your way, right? Very, very important, you have to show your way. So we start with the probability of picking one red, one white, plus the probability of picking what? White and red. The arrangement doesn't matter. The probability of picking two white balls, right? So you arrange this way. And then, what is the probability of picking one red, one white? 21 out of 90. White and red? 21 over 90. And then, two white balls? 6 out of 90. You can see that this will not give you problems. Just like 90. The lowest common multiple, right? And then you add the top. So you have 21 plus 21 plus 6. This gives us what? 48, right? So you write. Imagine if you had simplified here, there was 5. You are supposed to start thinking, see what is the common denominator. You waste time. That's why I didn't reduce there. You see? Yes. But the final answer, I must emphasize, must be reduced. So what is common again between 48 and 90?
2.
If we say 2, it gives us 24. There, 45, right? Again, 3 gives us 8. 3 gives us 15. So we conclude that the probability of picking at least one white is what? 8 out of what? 15. Okay? We have come to the end of our lesson for today, right? Yes. My name is Edward Siani from Katete Body. On behalf of our TV crew, it's bye for now.
Bye.